Damn, I have been waiting for this day for a while. Well, this is a series where I take a look at one of Flat Earth Flyer and discuss/debunk one section at a time. This video is looking at the very last paragraph. I have actually managed to reach it with hopefully most of my brain cells. This video is all about boats over the curve. It is a common misconception that boats disappear out of sight because of the curvature of Earth. The introduction of the Nikon P900 and P1000 have posed a real problem for the supposed curve of the Earth. Just zoom in. First, we'll go through their initial claim. Then I will try to touch on some arguments they often make when it comes to this kind of photos. Finally, we will talk about the famous black swan. So, buckle up. First, can we talk about our eyes? They suck. Really. It is a horrible, horrible design that either proves evolution or a really, really bad designer. We may start with the 2020 vision, but then some of us develop conditions where things far away looks blurry. It can be where things close to us would look blurry. Hell, one can even get a condition where everything is blurry. We use this amazing invention called spectacle. Thank you, Nevin. But even with my glasses, when I look across to my neighbor's house, I can see her Venetian blinds, but I can't count the number of blinds visible. Wait, being a creepy voyeur, I can bring out my Minolta camera with 200mm telephoto lens, and guess what? I can count them quite well. If I had a binocular, I could have done the same thing, or a telescope. So what is happening? Why do I get to see the individual blind with additional aid, but not with my naked eye? Obviously, the simplest answer is zoom. Well, yes, it magnifies the image being viewed. Refraction is how it magnifies, but the real question still remains. Well, to understand it, imagine those Venetian blinds. Let's make them horizontal blinds for our example. Now suppose they are not overlapping each other, but each blind has a gap between the side blinds. So when you're looking at any two blinds, you have a little gap between them. Let's ignore color, shadows and such artifact. It's really the gap and the contrast in between that allows me to count the blinds from my distance. Now imagine a line from the bottom of the upper blind to our eyes and then to the top of the bottom blind. That angle it creates in our eye is the key. Angular resolution, and is calculated by 1.22 lambda, where lambda is the wavelength of light, an average of all different wavelength divided by the diameter of the aperture of the camera or our eye. Anything less than that angle, well, we cannot distinguish it anymore. So the angle from those blinds, when it is greater than said angle, I can spot the gap. A more elaborated explanation would talk about diffraction, diffraction pattern, and so on. If you want to learn more, do a search on Rayleigh criterion. If I can find it, I will link a video by Conspiracy Cats on this subject in description. Now, here is a misunderstanding that is waiting to happen. Cameras, binoculars and so on, when they talk about aperture but also zoom, and those are different measurement. For example, Nikon Coolpix P1000 Super Zoom camera has, as of July 2018, the world's longest lens, coming in at 24 to 3000mm equivalent, with a maximum aperture range of f2.8 to f8 with 125x optical zoom. Just to keep it in mind if you wanted to do any calculation. But for our discussion, that should be enough. Imagine you're looking at a car driving straight away from you on a flat plane. as the car is going farther and farther, well, what you perceive, aka from your perspective, it seems to get smaller and smaller. Now, if it's not a square shape from your point of view, then both top to bottom and side to side has two different angular resolution to your eye. On a normal car, the top to bottom is less than side to side. So at one point, you wouldn't be able to distinguish the top from bottom, and if it was wide enough, it would appear like a line instead of a rectangle. Once the side to side angle is less than the minimum resolution for your eye, well, you can no longer see it. Bring in some magnification, you are seeing it again. Then again, as it moves further and further, at one point, that same thing would happen to the new aperture. Hopefully that explains how we bring things into view by zooming and magnifying. Next, well, this is so simple that I'm wondering why I'm about to say it. Once you hear it, you'll wonder why I'm saying it. But well, if the flat earthers knew it, they wouldn't be writing this shit, right? On my debunking horizon eye level video, I talked about perspective, vanishing points, parallax and such with greater details. So please check that out if you want to know more. In this, well, I don't want to repeat myself, so maybe a summary and different example. I'm sitting about 4 feet away from my monitors. The one in middle is 16:9 screen. Now, if I get a small piece of paper with the same ratio, I can close one eye and hold this piece of paper in front of the other and try to obscure my monitor. As I move the paper back and forth, at one point, it will just be barely obscuring the whole screen. At that position, if I move the paper left, right, up or down, part of the screen comes into view. So that piece of paper at that distance appears to be exactly the same size as my screen. I can then imagine something bigger, farther away, with the same ratio that my screen is blocking and so on. Next, if I put something in front of my screen, blocking half of it from view. So now the visible screen is 16:4.5. Guess what? I now need a piece of paper with the same ratio to have the same effect I had before. Without any other variables like obstruction, refraction, curvature, and so on, items would retain the same ratio over distance. Only the scale would change. Again, without external variables, on a flat plane, if you see a large pillar with top half painted red and the bottom half painted yellow, well, it doesn't matter what distance you would view it at, it would still look half red and half yellow, even when it goes out of view and we bring out a Nikon P1000. Pretty obvious, I know. Yes, we do say boats disappear out of sight because the curvature of Earth, but to be more accurate, we say boats disappear out of sight from the bottom, and that bit is pretty important. So that pillar in our globe model would slowly disappear from view where the red-yellow ratio would change. We predict at one point you'd only see half of the full yellow and the complete red. Soon you will only see red part and then nothing. Oh, and trust me, the point where you can't see the yellow, well, a Nikon might bring the yellow back to view, but not the complete yellow. And even with your Nikon, you will soon have only red. Well, I guess that wraps it up for that paragraph. Now, bonus materials. During all these examples, I kept saying without external variables like refraction, and this is why. I have covered refraction thoroughly in one of my other videos. So here, a quick summary. A refraction is when light from one transparent medium enters another transparent medium. Imagine a line perpendicular to those two medium surfaces. We call that imaginary line normal line. Now the higher the angle is between source light and this normal, the higher the bend would be. If the light hits at 0 degree, there would be no refraction. We have Snell's law that gives us the equation needed to calculate this. Now imagine the sun at horizon. Obviously it is noon at that point for someone else. That person has the sun almost above them. So the sun rays that you're seeing is coming to you over greater atmospheric distance at a higher angle. This beautiful cosmic dance creates some wonderful phenomena. Did you know that most of the time we get to see the sunrise before sun has actually risen? Similarly, we see the sunset after it has actually set. Similarly, during certain months of the year, we get to see Mount Canigou from Marseille, that is over 250 km away. In my We See Too Far video, I explained this phenomena. Refraction is truly wonderful. Again, please see my other video with examples of refraction. Right now, I will just assume that you believe in it. When the light from outer space reaches our atmosphere, and from there all the way to our eyes, well, it has already gone through many layers of refractions. But that's not all. One example that I had previously used was a campfire, and how the person opposite you would appear to shimmer. That happens due to hot air rapidly moving, and as the temperature changes refraction index, the light refracts many times through moving air and appears shimmering. Now think of bodies of water. It evaporates in heat, and thus we have rain. Yes, I know ice has something to do as well. Imagine as the surface of the water is getting heated. The evaporated molecules are obviously warmer, and it rises high up in the atmosphere where it condenses. At the right weather, you can even see this evaporation and the shimmering it causes. We will not even get into things like humidity, dust, and other particles that can block, reflect, refract, and generally play havoc with the light. These are all primers to get you ready for coup de grace, Black Swan. But one final thing before that, and this is super cool. The floating city of China. This amazing video was wrongly attributed to a type of atmospheric superior mirage called Fata Morgana. So what is a mirage? Well, this is the optical illusion when light is bent by layers of different temperature air along the Earth's surface and causes displaced object. It can be distant object or the sky. So whatever we are seeing actually exists. So when we see water mirage in desert, it is really part of the sky displaced. Obviously, we can't leave it at that. When object above the horizon appears under the horizon line, well, we call it inferior mirage. When object from below the horizon line appears above the horizon, well, it's superior mirage. Floating city, just because most people assume it has to be projected from Earth's surface, thus superior. Instead of the Occam's razor, it's a doctored video. If you want to know more, one of my favorite YouTuber, Captain Debunk, did an amazing video on it. Link in description. But Fata Morgana is amazing to look at. It is an extra shimmery, multi-layered type of superior mirage that doesn't happen very often. This also makes distance boats seems to hover above the ocean surface. How cool is that? Unfortunately, mirages can only happen very close to the horizon line. Darn. Well, it's because that view at which the refractive properties are most prominent. Well, enough of that cool stuff. Behold, Black Swan. Now, some believes it's called Black Swan because one of those oil rigs look like a black swan. Personally, I would like to give them a bit more credit. At one point in history, people in Europe only observed swans that were white and assumed all swans were white until someone brought over a black swan. The idea being it is something no one thought was possible until they saw it. And thus, this image is like that elusive black swan. I did talk about this black swan history in one of the other videos. This is where I think I want to be lazy and at the same time appear very zen-like. You already have all the tools needed, my Padawan. From what I have talked about so far, you should immediately see or explain all, if not most, elements of this photo. And that missing explanation would be my fault for not giving you dimension of the whole oil rig, and thus you would calculate how much of the holding pillar is truly showing. In case you want a hint, can I say that cranes are generally straight? Well, that's all for this video. Thank you so much for watching. If you have enjoyed this content, well, a like and a comment won't go amiss. If you'd also subscribe for future contents like this, it would definitely help my small channel grow and would be thoroughly appreciated. Have a safe day. Signing off.